Hey guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show. Well, perhaps we better start from the beginning. So I've had this goal now going on 2 or 3 years. And I love to travel. But unfortunately, the time that I'm away from the workbench takes away from the thing that you all want to see, which is the stuff getting repaired. I understand that's my primary function in the radio world. But we're losing guys at a phenomenal rate. And I mean phenomenal rate. And because of you all, I have been totally blessed with this large platform as far as radio is concerned. Not overall in the overall scheme of YouTube, but this particular platform, I have the ability to reach out and reach a lot of people. And I'm not going to lie. I feel the pressure of that with every one of these videos. I do. But I've had a goal now to try and get every person's spoken history that I can lay my hands on. So the future generations or the fellow radio operators, we can at least know who these people were. So I had the opportunity. I had a project that I had to go do in California. And I thought I would take advantage of that. And in my travels, I found a few guys that were willing to be the first. The first one of these videos I ever did was with Motormouth Mall. Everybody watched it. And I mean, like, everybody. This is a different format. This will be a different format. And I think you guys are going to like it. I found a few guys that were willing to sit down and just basically share with me and all of you their personal history in radio. And there's several of them that want to share with you all what they're currently doing or what they're going to be doing. And one of them is going to be Motormouth. Motormouth is who we're going to interview next. John has always been very accommodating. Opens the doors and says, come on in. I'm radio 100% of the time. And he is literally the embodiment of radio. He picks no fights with no one. He has no ill feelings towards no one. He just simply wants to do radio. And I think that you guys are really going to enjoy this interview because John was willing to sit down and speak about his current antenna project and his upcoming antenna project. I think you're going to enjoy it. I really do. On that note, gentlemen, let it begin. Well, I guess we can just kind of pretend like this is a handoff microphone of some kind, I guess. Let's be happy and get ourselves in the mood here.
All right, yeah. Hello, YouTubers.
Hello, Mr. John. How are we doing today?
I'm doing absolutely phenomenal, and you?
Doing all right. If you want to take him, throw that on your
I
shirt.
can do that. I'm gonna throw this on here. And
So we're here with Motormouth Mall today, and
How's
he
your work?
is wanting to cover a couple different topics, and I think we're going to start out with your antenna, yeah?
I think so. I think that weird Jampro antenna might be a good place to start.
Well, that's outside, and we're in here.
Well, let's take this camera outside and
on the road.
take
Show's
a show on
gonna
the
go on
road.
the road.
Out the door we go. All right, so wonderful antenna, everybody. I know there have been a lot of questions asked about this strange antenna. This is the first time this antenna has actually been modeled and built and designed for HF. Normally they're used as a FM broadcast style antenna. for the FM broadcast band between 88 and 108 megahertz. For 18 or 20 years, I've been wanting to design and build one of these things for 27 megahertz, and it just figured now was the time to do it. So here it is. I started out with a single unit. One end of that antenna is one bay, and the other end antenna is a second bay. Normally on a broadcast tower, they're stacked one above the other, and they'll stack them, 2, 3, 4, 5, 6 bays high or more. Usually the flatter land stations will stack more of them and squish the beam pattern so that it becomes very flat and covers a greater distance. And in a city where you might have people at the base of a mountain, they might use one, so you get the big, huge lobe and cover down below, as well as cloud burning. At any rate, there's circular polarization. Each individual bay is a circular polarized antenna. It takes 2 bays to get a unity gain of 1 in either plane. So 2 bays will give you 1 dB of gain vertical and 1 dB of gain horizontal. Obviously, you've got to split your power up between the two. So what you lose, you can look at it as a plus and a minus. You lose half your power in one plane or the other, but you pick up 17 dB in the plane that you were not able to be in prior. So what's a loss at one is a big gain at the other. And then because it's circular, as the conditions change and the ionosphere changes and your polarity changes, both elements come into play at different times. So what you lose in overall ERP, you pick up in tickling Mother Nature just the right way. So the next question people say, well, what kind of a pattern does that thing exhibit? Well, it's sort of a big clover leaf. I did this design initially expecting a figure 8 design, and my gut told me to use a half-wave spacing. I talked to JamPro, and their engineers said that we find the best gain at 1 wavelength. So 1 wavelength it was. I didn't question it. I decided to go ahead and try 1 wavelength. So at any rate, at 1 wavelength, the pattern is not a figure 8. It's 2 figure 8s. The biggest figure 8, the biggest lobe, is actually in line with the antenna. So right now pointed, that way was north, which is actually backwards mirror image, and that way is south. And those have the big lobes right now. Perpendicular to that are the small figure 8 lobes. That jet might be making too much noise, huh?
Yeah, I think they're going to turn right over the top of us here.
They may.
You can throw that mic in your pocket, man. With a pad.
Well, I can do
It's
that.
got a range like a mile on.
Oh, all right. Well, in that case, I don't have to hold on to the microphone. So anyway, there's 2 patterns, 2 figure 8 patterns, which also yields a bunch of small nulls. Now, the gain difference, if you will, between the small figure 8 and the large figure 8, which are 90 degrees apart from each other and symmetrical all the way around, is roughly 1 S unit or 6 dB gain difference. So I do have some directionality, though it's relatively an omnidirectional antenna. The pattern is like a clover leaf, like a big clover leaf, only the shape is like a big lobe and then maybe a smaller lobe and then a big lobe again. And then these nulls that are created are tools that can be used to knock out interference. So if I was pointing to, say, Tucson, Arizona, and getting interference from somebody in Georgia, it just so happens that I can point the null to the person in Georgia, and there's enough of a big lobe left over to where I still hit Tucson and I don't have to hear Georgia, for example, or whoever that interfering station might be, or whatever direction they're coming from. And I have multiple of those nulls and multiple peaks, so I can pick and choose a little bit better than I could if I just had a standard Yagi. However, and I once said, we'll get into the intricacies of this antenna in a little bit, but I once said that I would never go back to a Yagi. I could never have been so wrong. And there is no such thing as the one best antenna for any particular application. CB radio, you think big long Yagi and that's all there is to it. Well, not so true. Sometimes you want the different takeoff angles, sometimes you want circular polarization, sometimes you don't. But if you only have one or the other and not the other, you're only part way there. So anyway, I found that this antenna, as impressive as it is and as cool working as it is, there are times where a Yagi is still the preferred antenna. So again, still no best antenna for the band, but the best antenna at the time as needed as Mother Nature requires. So at any rate, we're going to do a Yagi again. But before I jump onto the Yagi project, let's finish up some of the way this antenna works. Essentially, you have two dipoles that are swept back, and they're twisted at 45 degrees angle, and you can see they've got a weird twist going on. They cover both horizontal and vertical, and the matching is achieved if you add one single bay. The matching is achieved by the two little trombone extension arms that slide from the center of the boom over to the two top elements, or the two bottoms. It really doesn't make any difference where you feed it from. So that's one individual bay. Now let's say you tune two bays to 50 ohms. Now this part will apply to any two 50 ohm antennas, but to finish the discussion about how the antenna is fed, essentially,
right there.
There you go. Where the antenna is actually fed in the center is going to be two 50 ohm antennas that provide a, well, in parallel, 25 ohm feed point. Well, you can't very well use a 25 ohm feed point. So what do? Most people use 75 ohm coax or various other ways at low power to transform that 25 ohms back up to 50 ohms. And I didn't have that luxury because I didn't want to use a limited amount of power. So I figured, let's go all out. I happen to have two chunks of heliax floating around. You see there's a loop up there. One side of the loop is shorter and one side of the loop is longer. And that is a transformer. What happens is the heliax goes up the tower, it hits a T. The T is a 1 5/8 inch EIA flange T, and it splits the coaxes into two different coaxes. And I happen to have one 2-inch air-filled heliax, and I had a 2-inch foam-filled heliax. And they were both 50 ohms. So the idea was, I didn't want to use, the other reason I didn't want to use 75 ohm coax is because as your coax impedance goes up, the distance between the outer edge of the inner conductor and the inner side of the outer conductor actually gets closer and closer, hence the more propensity for arcing internally. So I thought I'd stick with 50 ohm coax, and I would parallel two quarter wave sections together. And so I electrically tuned with the MFJ, actually with the Rig Expert, I electrically tuned each section so that they were 2 quarter wave inch coaxes, even though one of them is nearly 2 feet longer than the other. The longer one is the foam filled, and the shorter one is the air filled. Is that the right way? No, other way around. Anyway, yeah, other way around. At any rate, they're both electrical quarter wavelengths. So when you parallel them together, you get 25 ohms. And 25 ohms in series with the 25 ohms that you've created by putting the two antennas together, 25 in series with 25, you end up with 50 ohms. At the top, where that little gray box is, which I don't need to point to, but at the top there's a gray box. And that little gray box, way at the top center, up there somewhere, a little gray box is a point where the two coax pieces have been peeled apart, the centers bolted together, and the outside resoldered with a piece of extra scabbed on shielding from another piece of heliax to form a tap or a T at the very top of that center part. I would have used EIA flange connectors, but I didn't have any more 2-inch EIA flange connectors floating around. So anyway, I made my own T, and at that point, the two equal length 50 ohm 7/8 inch lines, one from each antenna, tie together and are all sealed and bonded up in there, and that is the joining tie point between the transformer and the two feed lines. So it looks goofy, it looks complicated, it's really not. And it's a one full wavelength spacing as opposed to a half wave spacing. And the half wave, like I said, would have been a perfect cardioid or a perfect figure 8 pattern, and the full wavelength spacing ended up like a clover leaf, which was a mistake. But now that I've been working with it and playing with it, it's a mistake that went the right direction. So anyway, that was dumb luck. My gut did say look for the half wavelength spacing, but when JamPro said that we find more gain at 1 full wavelength, that's what I did. Anyway, that is the breakdown of the JamPro antenna, which normally sits at 75 feet. It's down currently at 23 feet right now, which means I have not been able to do well in Hawaii. I have not been able to do well in Florida. I have not been able to do well on the East Coast because all my energy is going up there. And NVIS doesn't seem to work real well on 11 meters.
Near vertical skywave.
Near vertical incident skip, right? Yeah. Does not work on 11 meters. So it's down for the purpose of having that other antenna that would be needed to complete this this array or this CB application as we know it. And BBI, I don't know if that camera is now pointed to where you can also see what's on the ground.
No, I've been leaving that out of frame because I didn't know if you wanted to.
Yeah, I'm gonna touch on that. I'm gonna go ahead and touch on the 7-element antenna that's gonna go up on the tower. And essentially, the boom is already made up. The driven element is going to be a split standard dipole feed. It's 7 elements. The fly wires are all 2100 Philistrand fly wires. The 2-inch boom that you see there is actually a fold-a-goal that I got from the scrapyard for soccer fields. And anyway, that's a 56-foot long boom that is going to be up at 36 feet. So the top of the second section of the tower is going to be the top of the second section is going to have a ring rotor on it. So I'll actually have the rotor control box in the studio. The first time ever I've had an actual rotor control box in the studio to turn my antenna. This is going to be really exciting. I'm looking forward to it. I might actually like join the competitive realm maybe. I don't know. Anyway, maybe not. At any rate, that antenna is going to be at 36 feet. It will have a full rotation all the way around the tower, and it should work pretty doggone well.
You're going to go with square boom on this one.
Square boom, yep.
What's your thoughts on that?
No difference except for the price was right on that. I went to my scrapyard, and my scrapyard happened to have a fold-a-goal, a big, huge soccer field aluminum fold-a-goal.
Right.
Scrapped. So I got it for 90 cents a pound, which is dirt cheap. So
once again, let's come back to that topic another way around. So what's your thoughts on square versus round? And what's your thoughts on insulated elements versus bonded or bolted to the boom?
Okay. Let's start with first square versus round. There is no electrical difference, no beam performance difference. The differences are things like being able to build it square, your elements are all flat, you don't have to worry about antennas twisting and being mounted off center because of the round, it's flat. So that makes things a little easier. As far as electrical issues with through versus grounded or insulated versus non-insulated elements, there is no difference in beam performance. There is a huge difference in element length requirements and a little bit more forgivingness in the ability to mount. If you put a through element through a boom and it's isolated from the boom, or on top of the boom, doesn't matter, but if it's isolated from the boom and it's the right length, but you get it slightly off center, the antenna will be a little bit forgiving. But if you take a solid element that is mounted to the boom, it needs to be exactly in the middle. Or you've got one element that you might have the right length element, but if it's offset one way or the other, it's going to drastically affect the performance of the antenna. But if both are assembled correctly and the measurements are done with that mounting, that particular, whichever way you go, that particular mounting method in mind, then the result in the antenna, there is no difference. So, no difference. I just use what I have on hand, and the square stuff works good, and I use prime. If you guys haven't been watching previous videos or pictures that I've made, and you guys are building antennas, you need to get from Prime Minister. He sells these really, really cool antenna to boom to mast mounting, or element to mast mounting kits, brackets. Now I used his on here, even though I use a square boom. I simply replaced the bottom straps with 2-inch square U-bolts, and I re-drilled 4 holes in each plate so that it would accept those U-bolts. But his element to mast mount, or element to boom mounting system is awesome. So if you guys want to build your own antennas and you want to use good quality hardware, there's always DX Engineering and whatever other sources, but you really can't beat Prime's brackets, and that's what I'm using on this antenna for all 7 elements, except for the driven element, which is on a big old half-inch fiberglass plate and suspended and isolated elements. You can see on the antenna right now there is part of the driven element in place already. And the way I decided to do this driven element, I don't know why it took me so long to figure this out, is I made the element lengths adjustable from the center near the actual feed point as opposed to the tips.
Or midpoint on the element.
Yeah, right at the boom level. So you can do your or your hairpin match adjustments and your antenna adjustment, element length adjustments, all from one location, instead of having to go out to the tips and stretch and shorten, and then play with the hairpin to get it tuned out right. It took me a long time to figure out that that was the way to do it. At any rate, so that's how.
Do you want to cover one question I've got?
Sure, absolutely.
What always drives me nuts is you hear about these guys that go and they slap the corona balls on the end of all their elements, and they don't compensate
the length.
I feel that I have a fairly decent understanding of how this works, but my opinion doesn't carry a lot of weight. You're the mad antenna professor, so could you explain to all these people out there, if you add corona balls to your elements, what do you need to do?
You've got to shorten your elements.
By how much?
Whatever the length of the corona ball is, and depending on how big the corona ball is, it could be there is no fixed level. I don't know how big. I've never used corona balls. I've never had enough power to need it. I've never had arcing issues. So I can't say I've had experience with them specifically.
Let's say like the shockwave antenna. So right. You get the T-top on top of that thing.
Right. And why that's there, I don't really know. I'm the one who.
The antenna.
Well, why do they need to shorten the antenna?
Otherwise, it'd be another like 3 foot longer, I guess, from what I understand.
No.
But that T-top takes like 30 or 40 inches out of the antenna by putting that T on the top.
Okay.
So have you ever done a study on like an actual corona ball or a capacitance hat on the top of the antenna, how much you can actually lengthen and shorten your element by that?
Not specifically by how much, no, I've never done that. Yeah. I'm the one who came up with the shockwave designs. It's funny how that came about. I looked at an old Mosley ad in a magazine for a business band antenna, and there was a picture of the shockwave, and there was also some other stuff that was similar to it but not exact, but there was a picture of what was the shockwave. It wasn't called the shockwave.
Let's be specific. Which shockwave are we talking about? The one that is produced by BM Technology, or is the one that's produced by shockwave antenna?
BM Technologies.
There we go.
All right. Yes, that's right. There is another shockwave. At any rate, so I saw this little black and white picture, and I thought, well, I'm going to build that same thing. It looks like it has all kinds of room for adjustment. And I reverse engineered it, and I built it, and then I thought, I'm going to sell these things. I'm going to call them voodoo sticks. Really clever. So I thought, well, what's an antenna go for these days online? So I'm looking at 5/8 waves online. This is, I don't know, 8 years ago. 5, 6 years ago, something like that, 7 years ago.
Time flies when you get older.
Time flies regardless. At any rate, I found that there was a J in the Mojave that was making I-10Ks and I-25Ks. I don't believe he's making them anymore, but I found them online, and they were like $300 and some odd antennas. And I also realized that I didn't want to be the guy that was going to compete against somebody else, especially with a design that was so similar. And so I thought, I don't want to sell these things. So I gave the design basically to Chris Hope at BM Technologies, and he ran with that. And he said, do you mind if I sell these? I said, no, I don't mind, I don't care. So he built the shockwave antenna, and my original design did not have a capacity hat, and it was a full, true, honest-to-goodness 5/8 wave driven element. And they work incredible. As a matter of fact, there's one on top of my building right now, and I love it.
We'll pan up there in a minute.
Not much to see, but just the driven element. All the rest of it's all down low at the roof. I use the roof of the building as my counterpoise ground plane. So tuning that antenna, if you put that same driven element and trombone system on a 4 radial system, it won't work. You have to retune it again. The better the ground plane, of course, it's going to bring your takeoff angle down to the absolute perfection of what a 5/8 wave can be.
And let's cover that. Ground plane radials on a 5/8 wave antenna.
Okay.
How does that affect you? I get this question probably 7-8 times a week.
All right.
The guys will call me and say, well, I got my Mtron, SolarCon, whatever, 5/8, 7/8, whatever antenna. How much difference does it make to have the ground plane radials present and not present? Go.
Well, huge difference. I mean, if you want, if it depends on who you're talking to. If you're trying to do a real high takeoff angle and a short skip, you probably don't need the ground radials. If you're interested in talking a longer hop and a lower takeoff angle, the only way you're going to get that is with ground radials. All 5/8 wave, quarter wave, half wave antennas are considered ground mounted verticals. They are intended to work, and their optimum performance is going to happen when you have a counterpoised ground plane, and the more of it, the better. Kintronics Labs did a study a long time ago, and they found out that 32 ground radials was the point that you really should shoot for. More than that, as broadcast stations do, is certainly better, but 32 is about it. Now 4 is enough to help out quite a bit, and it's a logarithmic kind of a thing. It takes a lot more ground radials to make a little difference, but 32 is where that I guess you'd call it the point of diminishing returns. So keeping that in mind, Kintronics Labs, it says 32 radials. We mostly use 4 radials. Some antennas only use 3. All ground-mounted verticals require a counterpoised ground system. So you be your best judge, but the more the better, and the lower the takeoff angle.
In simpler terms, what he's saying is the RF will go towards the sky in this pattern, but if you put ground plane radials on it, the pattern opens up, and you're talking more.
And what happens is angle of incidence equals angle of reflection. So if you're bouncing up high and you hit the ionosphere, you're going to come down short. If you bounce out farther, you're going to come down farther. So it's just like a pool table. Angle of incidence equals angle of reflection, and that's all there is to that. So, and you never know specifically what the takeoff angle is going to be, but you know, it's more or less what it is all the time. Franken-Jeep. This is Franken-Jeep. It's got the Cummins turbo 6-cylinder intercooled.
What's in the box right above your head?
Huh?
What's in the box right behind you?
Oh, this little box. Yeah. That's the infamous DDRR antenna, dynamic discontinuity ring radiator antenna. And it's 4 inches tall. It's 30 inches in diameter. The feed is a shunt feed. And the capacitor at the tip of the ring to ground is a 15,000 volt, 3 to 30 picofarad vacuum cap. And it's a 1 channel at a time antenna. It's got a lower takeoff angle than any of the vertical whips I've tried. Predator 10Ks, 102-inch steel whips, Francis and Mazers, 7-foot fire sticks, all of the above. This DDRR antenna performs better than all of those. It has one odd thing, which is actually a plus, and that is where the feed point is, or the gap of the antenna, in that specific direction for literally like maybe 4 degrees, it's got a pretty good null. So if you want to T-hunt somebody, you hunt the null, not the peaks, and that gives you a really good null to hunt. And for the most part, it's omnidirectional. It's vertically polarized, and it doesn't hit trees. I put a cover on it just because, but the cover has no effect on the antenna.
The antenna is what? What is its physical construction?
It's a copper tube. It's a 3/4 inch copper tubing, 30 inches in diameter, 4 inches tall, grounded to the vehicle itself. It's actually physically bonded to the vehicle. And then the feed point is between ground and somewhere along the short section just after it bends and starts going around the ring. That's the feed point. And at the very end, that antenna comes all the way around, and at the very end, at the gap, there's a capacitor to ground. And that capacitor to ground is 3 to 30 picofarads at 15,000 volts.
Explain to them what you explained to us last night, me and Steve, while we were here, why the capacitor has to have such a high kV rating.
Ooh.
And why it is so narrow in its response, the vacuum cap.
The whole entire antenna has got an extremely tight Q, and it's a quarter wave radial. And of course, as we all know, the high voltage point on any antenna is going to be at the very far tip of that quarter wave radial. That voltage with an all I have in here is an 8-pill. The voltage with an 8-pill amplifier at 1600 watt peaks roughly is right shy of about 13 kilovolts. And so a 15,000 volt cap doesn't blow through. I've seen other homemade caps that I made, and there's some videos you've seen and whatnot of fire literally coming off the tip of the antenna and burning and smoke just bellowing out of the antenna. That's because the capacitor didn't have the breakdown capabilities, and it punched through and it arced and it burned and it smoldered and it did all kinds of things with RF and as I was talking. So you need that very, very high value of voltage handling on the capacitor with this type of antenna, which is a limiting factor to how much power you can run. It's all a matter of how much capacitance you can, well, how to keep the value of capacitance the same, but how to make the capacitor big enough to where it doesn't arc at the higher voltage. And then beyond that, if you were to make something that ran higher, now you have X-rays to worry about as you approach that 15,000 volt mark and a gap in a vacuum. You've got a beautiful X-ray generator right behind your head. So probably not the best antenna for any real super high power applications, but it's a very high Q antenna, meaning it's only good for one channel at a time. And the way I tuned this antenna is the vacuum variable tuner that's in here has got a speedometer cable hooked onto it that rolls through the roof, and behind my head there's a knob, and I can remotely tune that variable cap while I'm watching my SWR and walk 4 or 5 channels in either direction, tune it, walk another 4 or 5 channels, tune it, and get from 28 down to 6 or from 6 back up to 28. It's a little bit of a hassle compared to this antenna, which is on a coax switch, and that's a Predator 10K with a cheesily modified top section so that I could hit trees and branches and not worry about the antenna, but it's a Predator 10K. And then it's mounted on a military mount that also lets me hit trees and branches if I have to, but not that I'd want to destroy the coil. But anyway, that's a modified hollowed out military mount, whatever you call it, a bracket, antenna mount. So that's basically it in a nutshell. It's broadbanded. That's not. All right, and this right here, by the way, is a single bay of the Jam Pro style antenna. This was the prototype, the very first one that went up. I kind of went,
you?
huh?
How tall are you?
Oh, 5'10".
Okay, I'm 6'4".
Yeah.
So this was the prototype.
This is the very first one on 27 megahertz ever made.
Go.
All right, so each element is a quarter wavelength long, and the spacing between the elements is a quarter wavelength. So for those who want to try to build this on your own, be my guest. The feed point it's all DC grounded. Everything, the boom, the driven elements are all DC grounded. And the feed point is nothing but coax, in this case hardline, 1 5/8 inch heliax with an elbow and all that, but you can use regular coax for that if you want. And if you want, you don't have to separate it, you don't have to hang it off the edge of your tower. You can build a bracket and hang it right from the center of the boom so that the balance and weight is all in the center as opposed to trying to hang off the tower, right? You can see how that works. But this is the way the real ones are made, so that's how I made mine. The feed point is at the center, the shield of the coax is DC grounded to the boom, which is DC grounded to the elements and all that. And the center of the coax connects to these 2 lines right here. And so the feed point is actually right here, and the coax center part tops out, and this is an insulator, and this is just an Andrews EIA flange connector that gives you a nice breakout of a center conductor and ground. It goes through these sliding adjustments, which can get longer and shorter as you tap the top or the 2 bottom. It doesn't make any difference which antennas you feed, the 2 top ones or the 2 bottom ones. But those can slide back and forth. You loosen the hose clamps, and they'll slide back and forth. And as they slide back and forth and twist, that's how you tune the antenna. That combined with the actual element length of the tips of each one of these. So you can see there's hose clamps on all the tips, so I can dial them all in. And if you've got the patience to tune it, it's a great working omnidirectional antenna. It's circular polarization, and it is what it is. And
can you answer the question that I have of
sure.
What difference does it make on your elements? Do they need to be at this angle, this angle, this?
Oh, this twist is 45 degrees. It's a 90 degrees won't work. 45 degrees works, I'm trying to show the camera.
Right.
45 degrees is what you're looking for, 22 and a half off the center on each one. So 45 degrees total is your difference between this element and that element opposite one another. If you put two of these antennas together, they both need to be fed on the same, either both fed at the top or both fed at the bottom, and they both have to have the same tilt. If you put one going, let's say the south antenna tilting this way, the north antenna tilting that way, and then you go to the other side and you swap it, you've changed the phase of the antenna. So if you do that, you're going to have to change that in your coaxial feed line. So keep things simple, and if you build two of them, make them all the same. And here, by the way, let me keep the camera where it is. This, by the way, is a, do I have another one? Yeah, that's the one right there. So for those interested in where this came from, this is an original penetrator made by JamPro. As you can see there, it says JamPro stamped right on it. And that was what this modeled from. And what they did differently on theirs is they used the inner diameter of this piece, which is, it's thick wall stuff. The inner diameter of this and the outer diameter of the tube that's brazed in here, all the way to this point here, and they stubbed out with just the center of the coax right here. It's really the same thing as doing the external mounted coax with the center stubbed out here. They just happen to make that simpler and all one hermetically sealed whatever unit. And those hang off the top of the tower, off the side, and they're fed together in multiple bays. So I saw that, and that was 20 years ago or plus, and I knew I wanted to build one. And 18 years ago, I scavenged these parts, seeing these pre-welded angles already on there, and knew what I was going to do with them. It took me all that time to finally build one. So anyway, this is a predecessor to that.
Juice.
Sizzling.
Juice.
All right, what did we talk about? Geez, where to start here? Cool to get to visit here with BBI and Steve Brockus. Kingpin was here yesterday. Oh my God, we had some meat. You probably saw the pictures on Facebook, but oh my God, these tomahawk steaks, unbelievable. Anyway, radio. I guess the thing that brings us all together and that you're all interested in hearing about and thinking about and talking about. Where to start? The first thing I might want to say is I could use some feedback, maybe put some comments on Facebook or comments on
right here on the video.
On this video, I guess, yeah, do comments here regarding how you all feel about maybe Motormouth Mall doing some sort of instead of just video gates, there's MMM video gates on YouTube, and that's all wonderful. And it's a tool. That's there for people to get to hear how they sound, to see how their performance is from one station to the next or against their competition or whatever. It's a tool. But so far I haven't taken it beyond that. A few videos here and there that I thought were kind of funny, like fire coming out of an antenna and so on and so forth. But what about videos that might be a little bit more geared towards the questions and answers about things like, high fidelity audio processing, dynamic headroom, amplifiers, how it all works together as a system. What do you got to do? What do you have to achieve? Not how do you have to do it. I don't want to be the guy that says you have to buy my product and you have to do this specific thing and this is how you're going to get what you want, and if you don't do this, it's not going to work. I'm not that guy. I do offer the modulator, and I do plan to, with the help of Dave Dowler, come up with a little circuit board that's going to make the modulator even easier to install on specific radios. But even just forgetting about whose radio you're dealing with, whether it's built by a technician somewhere else, whether you did it yourself, whether it's direct injection, whether it's my modulator or even something else. It'd be nice to be able to have a way to answer general questions, how to implement all that. And implementing it is not as easy as just plugging it in. There is no real such thing as plug and play. Because as soon as you enter the world of wideband audio and audio processing, you open the door to the multiple ways of getting there. And obviously I got my preferences is live professor or computer-based audio processing for various reasons. We can get into that later, but that's not really the issue. Or how do you run your amplifiers? How do you gain stage your amplifiers so that one properly feeds the other? Is it all about running everything to the max? No, it's not. It's about having the final outcome be what you don't want it to be. But how do you get there? Maybe there needs to be some interaction that bonds the concept of, okay, I've bought the radio, I've got the audio processor, I've got amplifiers, and multiple amplifiers, and antennas and coax, but what do I do with it? How does it all work together, and how do you feed everything to make everything all happy? Maybe it'd be kind of cool to see if everyone wants a YouTube video or a show or a periodical that covers those kinds of things. Let me know, or let Luke know, and I'm sure that we'll figure out some way to make that happen, and I'm willing to do that. Right now I have pretty poor internet service, as you all know. You've seen my video gates, and there's a pretty good delay, or it's choppy, or the graininess of the video, and you're trying to look at the beautiful SDR receiver, and the lines are all fuzzy because you can't make it, and you can't read the S meter. I apologize for that at the moment, but I'm working at getting my internet to be a little bit better, and as soon as Starlink is available here, I'm all over it. Plug for Starlink. Okay, well anyway, I didn't mean to do that, but I did it.
So the thing is that you're trying to stream live, you don't have the bandwidth to support it.
Correct.
So if you were to go and shoot your own little videos,
Yep.
edit them all together,
Yep.
and when you upload them, whatever the resolution is that you're shooting and editing the video at,
Right.
it's just going to take longer when you upload.
Okay.
So you'll have high resolution on the other end.
Well, then I can do that sooner than later, I suppose.
If time lets you.
Right.
Because I know you're just as busy as the rest of us.
Oh yeah. There's this radio is not the full-time job. It's a hobby. It's a hobby that I like to do for myself, obviously, but I like to do it to benefit others and to help others. And the payback that I get from that whole thing, it's a selfishness part, I guess. The payback I get is I get to hear good sounding radios in my radio. I get to hear Grandpa Joneses and derails and you know, prime ministers and people who have an interest in going down the road of wideband hi-fi, good quality audio. I drool when I feel that kind of, when I hear that audio. I could be in the other part of the shop and I hear that rumble of some deep killer audio roll up there, even 12 and backscatter or anything like that. And it's like, ooh, my ears perk up. That's what I want to hear. I don't want to hear the nose pinched, tinny, tight, wound up kind of a weird sound. So the more I can help people, the more I get that in return. So that's my selfish reason for wanting to help people. And I know that there are a lot of people that know that they want to get their radio to the next level. They want to get to that big sound. And how do they do it? So if I could help people in some way, let me know. If you have questions, let me know. And I'll try to address those questions in videos. Maybe not one video a week, maybe a video a month, maybe a video every 6 months. But the longer between videos, the more I'll try to cover, and the longer the videos might end up being. I don't know. Maybe I got to rethink that. But at this point, I'm open to it, and just wanted everybody to be notified that may be in the works, and I'd be open to that kind of an idea. So anyway, I think that's enough about YouTube. So I don't really have a particular direction beyond that I'm going to go in, and when I'm going to go do it. I don't really want to get too don't want to make too many promises too quick.
We're going to edit all this out anyhow.
Okay, good. I don't want to make a whole lot of promises real quick.
So what are the next points you want to go? What's the future for motor mount mall technologies, you think, that you're willing to talk about right now? I know we got that one project you're talking about. We're not talking about.
And I don't want to talk about that one. I believe that's going to facilitate making what's already happening happen even easier for a lot of people. And everyone's ears are going, what are they talking about? Well, stay tuned. Dave and I are working diligently as we speak on a new product. That'll be basically the same, but just a little different twist and a little bit easier to implement for most people. Let your imaginations go with that for a while.
I thought it was really interesting at breakfast, and I never thought about it the way you articulated it to me this morning, is that the motor mouth mall technology is really multiple different things brought together to sound a certain way and do a certain thing. And do you want to cover the motor mouth mall tech per se?
Right.
Half of it is controlling the radio and controlling the signal. and then you can split that and divorce it, and your audio is your own separate.
Exactly. Yeah. Yeah. There's a misconception, I believe, that the modulator has a sound. That the modulator, motor mouth Mull's modulator is this, or that the motor mouth Mull modulator in any way, shape, or form is attached to a PC. And it's not. They're all separate from one another. And basically what the modulator does, for those who don't know, is it lets you have full and discrete control over your envelope growth and doesn't have a limitation on bandwidth. So what you put in comes out. There's no EQ curve built into it. If you put 1 volt peak to peak in at 10 hertz, you're going to get a fully modulated 10 hertz sine wave. And if you put 15 kilohertz or 10 kilohertz into it, you're going to have the same level of amplitude, the same envelope growth regardless. So it's flat. And that's what it gives you. It also gives you control over what your carrier is and how much audio it takes to get that carrier to nearly pinch off and then come back up again. And then above your 100% positive peaks, it allows you to have more and more and more positive peaks. And of course, that leads to the next thing that we'll talk about in a little bit, and that's headroom, dynamic headroom, and versus carrier and signal strength.
Ratio.
And the ratio thing, which I've really grown to hate the term, but we'll talk about that in a little bit.
I'll leave you alone.
All right. So at any rate, the modulator does not have a sound. It lets you have control of your envelope growth and bandwidth. All of the sound that you create, the bass, the treble, the compression, the reverb, the combination of all those things pooled together, no matter how you do it, whether it's rack gear, W2IHY stuff, UR6QW stuff, Live Professor, Pro Tools, Ableton Live, you name it. Any number of those things are just ways of manipulating your audio to get your energy within the desired curve to be in the proportions it takes to get the bass and the treble that you wish to have, and that works best for the receivers that you're catering to, and the amount of compression it takes to get the effect that you want as far as density goes, and the reverb and all those kind of effects, and even harmonic distortion and all the other kind of stuff. That can be done any number of ways. There's no right or wrong way. So anyway, that breaks it up into 2 parts, and none of that is a motor mouth sound. You can take somebody like Prime, for example, and he did a video gate where he mimicked my processing scheme. He mimicked it so well, when I heard it, I had to think, wait, is that me? No, that was Prime mimicking me using an audio processing scheme that I would probably use, and he was dead on the money, and it sounded like me. It was amazing. Anyway, so there is no such thing as a motor mouth Mull sound. That's something you create and you do. You make your sound your own. And the modulator allows it to happen. The processing is your canvas that you paint your picture on, and you make it happen how you want it to happen. So that's basically all that is. Now, as far as the dynamic headroom goes and the term ratio, there's been this big, huge... People are now understanding that at 100% modulation, a sine wave on a carrier will show 4 times PEP generally, okay, not to the actual number, but roughly 4 times PEP greater than what the dead carrier started out to be. And so they have decided to make this 4-to-1 ratio universal. So they failed to count whether or not this is a flat-topped ratio, or if it's truly sinusoidal ratio, or is the ratio being achieved by some magical thing where you would normally be overmodulated, but you suck up audio to get the carrier right, or you would be undermodulated. Is it carrier control? There are a lot of ways to get this ratio. And some people say, oh, you need a 3-to-1 ratio. Well, why 3-to-1? For one, we all know that textbook modulation to pinch off the carrier and to grow 100%, if you have 2 sine waves on top of one another, right? 2 perfect sine waves, if you make them any bigger than they are based on their spacing apart from one another, when they converge together, they're going to flatten. They can't go any farther together, right? Then they flatten, and then they come apart again. And then they flatten, and they come apart again. So you can't exceed that. But when you get to that point where they just pinch off, they also go up. It's a sine wave, so it's an S, right? Half of the S is on top of the line, half of the S is on the bottom of the line. So as much as it goes down, it goes up. And so if that's the case, your 1 watt carrier grows to 4 watts PEP at 100% modulation. So if you have a 3-to-1 ratio and your carrier is higher and you only go up partway positive and all the way down to negative, what are you missing? You're missing loudness. You're missing the sound. But what have you gained? Why do people do 3-to-1 versus 4-to-1? Because it gives them a bigger hammer, a bigger carrier, right? And remember, I guess my left and your right is all backwards. So anyway, it gives a bigger carrier, left and right. I figure out my left and right. Anyway, that bigger carrier, to make a half a dB or a half an S unit difference, has to be 3 dB bigger. That's doubling your power. So if your amplifier doesn't have the headroom to make the big positive peaks, and the positive peaks are what they are, that's your absolute limit, you can only back time from there. So if 1/4 of your full peak power output is your carrier, that will allow 100% positive and negative peaks. Textbook perfect. So why shoot your audio in the foot by trying to get the little bit bigger carrier when you can't get enough out of that carrier to make a substantial difference at the other end? Now on your watt meter, granted, that big old carrier may look humongous, and you might think, oh, I went from a 25 watt carrier to 70 watts. And yeah, the amplifier can make that happen, but the positive peaks can't get any bigger, so you've lost your positive peaks. You've lost your talk power. So that ratio thing, even at the 4-to-1 correct, if you want to say, is only correct under the situation where you have a sinusoidal. As soon as you boxcar or square off your audio, we're not talking about apples and apples anymore. We're talking about something different. So try to look at the picture on a scope in your mind. And if you have a squared off boxcar looking signal, the area under the curve is going to make an RMS watt meter swing more. Don't use that as your 4-to-1 ratio. Look at your peaks. And as soon as your peak meter stops growing, even though there's all this RMS swing talk, even though you hammer the audio harder and your peak meter stops growing, but your RMS meter continues to go, that doesn't mean you're making more power. That means you're creating a big square wave. And you can create the sound of that square wave and the density of that square wave in the audio processing realm, and then take that audio processing that you've beautifully created to mimic that distortion that you're looking for and properly put that on a carrier and make it textbook perfect 100% modulation. Or you can take it further and go asymmetrical and have 125, 130, 140% positive peaks. People say, oh, we don't want asymmetry. It's distorted. No, it's not distorted. If it was bad, it's distorted. Let's use this term.
Oh, the distortion.
Let's get the distortion term ironed out first. There is distortion in asymmetry. Do your ears necessarily hear it? No, not really. The FCC would not allow 125% positive peak modulation on commercial AM broadcast stations if this distortion was bad. There's a benefit and a gain to be had by having asymmetrical modulation. They allow it. Now, just because they allow 125% doesn't mean that that's the max that you should use. My station's running at 200% positive peaks, and music and everything still sounds relatively good. Does it sound better at 100%? Is it a little bit crisper and cleaner at 100%? Yes. But is it louder and more commanding and more ear-catching at 150% or 200%? Yes. So I think that it's important to just remember, yeah, it's distortion, but it's good distortion. It's kind of like the musicians that play bass guitars, electric guitars, and they've got these new cool preamps, and they've got these hot gain stages on the input of their amplifiers that when you turn them up, they start sounding fuzzy, but still warm, but maybe louder and more grunty and more harmonic filled. That's distortion. But the musician deems that as the result that they want to be obtained. That is a desirable thing, so hence the distortion is a good thing. That doesn't mean that when they put it on the vinyl record or on the CD, they max the CDs out beyond the ones and zeros available. It doesn't mean that they cut the vinyl so doggone hard that you can't listen to it. It's a generated distortion that has a acoustical sound that they're looking at, and then that distorted sound is put into a medium the proper way. So it's the same analogy, I guess. So anyway, so the whole envelope growth thing leads us to dynamic headroom and amplifier stages hitting amplifier stages hitting amplifier stages. A lot of people in this hobby tend to think that every amplifier they have has to put out all that it can put out. And that's definitely not the desirable method. What matters is what's coming out of your final amplifier, your final stage. Whatever it takes to make that final stage happy is what it takes. If you happen to have a 500 watt amplifier that you're using as a pre-driver and you're only keying it at 25 watts and getting 125 watts or 180 watt peaks out of it, that's okay. And if that's what it takes to drive the next amplifier stage, which is going to key up at 125 watts and peak 15 or 17 or 1800 watts, that's okay. And if that drives the big huge tube that then puts out a clean signal, just because you're letting all your amplifiers loaf, that's where you want to be. That's what creates envelope growth and dynamic headroom. And it eliminates that nose pinched, tightened up, wound up, overcompressed, saturated sound that I think we're in this hobby trying to get away from and trying to lean more towards a full, open, rich, big, broadcasty kind of a sound. Not everybody. There are a lot of people who are totally content and happy with, you know, overdriving and saturating their amplifiers and cramming the microphone down their throat and clipping limiters. But I think more of us are leaning, I think if you're watching this video, chances are pretty good that you're starting to lean towards quality. You've been introduced to what quality is in an amplifier. You've seen BBI's workmanship in amplifiers. You've seen what goes into creating quality. So I'm assuming at this point of the game that if you're watching this video, you're probably still glued to the idea of wideband or relatively wideband. I don't want to say high fidelity. I used to say high fidelity. And in relation to what radio was, it's high fidelity. But what it really is it's extended bandwidth amplitude modulation. We only go down to maybe 50 hertz and we go up to 4.5 kilohertz, hopefully, or 5 kilohertz max. Because beyond 5 kilohertz, your energy is rolling off into the adjacent channels. And some of us care about adjacent channels and some of us don't. I don't always, but I still at least try to keep it, you know, relatively within my channel. If I go a half a channel in either direction, so well, I'm not going to say it's good or bad, but I do. But at least I don't go out 7 or 8 or 10 channels in either direction.
That's what we call wasted power.
Wasted RF, yeah. Look how much energy it takes to create 9 S units on somebody's radio 7 channels away.
Power. It's not doing you any good.
No.
Because the receiver, like you said earlier, you're trying to cater to a certain kind of receiver. What's the most common receiver in the CB?
Your typical CB radio is 300 to 3,000 cycles per second. That's it.
Okay, but your bandwidth that the receiver can actually receive over is only about what, maybe 8 on a really good radio, 8 or 9
on a really good radio. Well, on my Drake, it's 6 kilohertz. On an SDR, it can be up to 20 kilohertz.
Whatever, yeah.
But beyond that, even 20 kilohertz.
Wasted.
Anything beyond that is certainly wasted. There are people who now, with the advent of SDR receivers, there's a lot of people listening at 20 kilohertz wide. And there are people who are back and forth having conversations and enjoying 20 kilohertz audio. And if there's somebody at the other end who can enjoy it, by all means, do it. You know, it's fine. But to deliberately try to talk on one channel and not deliberately wipe out 10 or 15 channels on either side is ridiculous. So we're trying to just focus on quality and focus on the bandwidth that we hear in our receivers that we're catering to, and you know, that just be mindful of what you do when you have to do your own audio processing, whether it's direct injection, whether it's modulator, whether it's whatever you're doing. You've got to be mindful about that bandwidth that you shove into the radio, because what goes in is going to come out, and so you have control of that.
I think we're We're gonna call this done, dude.
Yeah, I think that was a fun trip, man. It was good to be.
See, what do we get in here for video? Oh, about an hour.
Wow.
Yeah.
Dang.
I'm tired. It's been a long trip, and I'm only halfway.
Yeah, you got a little ways to go yet. Got to go hit Bakersfield next, and then on the way up from there to.
Where's 63 from here?
About 100 miles east.
Great.
Yeah.
63 tonight, and then on tomorrow I go. Let's see, what day would that be? Today's Tuesday?
Today is Tuesday, all day.
Yes, and I go to Sacktown tomorrow. That's going to be the long leg from here, from him. And then get myself set up there, and then Thursday is tube day.
Wow, that's going to be fun. That's going to be a neat experience.
I got a lot of questions about tubes and the internal architectural structure, like why can't we take the stem off of a 3000 or like a 3CX 10,000 and put it on a 10 or a 15 and a 20 and vice versa. What's the internal structure difference? I want to see it.
Right.
I want to have somebody that builds them explain it to me, and I want to cover all the kind of questions like why do we got to turn the tube on and let it degas, or do we not really need to, or you know, the voodoo. Remember we were talking about antenna voodoo?
Yep.
Hey, you got the experts that there's voodoo that we're gonna get. Oh, that voodoo you do so well.
Whole lot of voodoo in this hobby.
So instead of going around with the voodoo knowledge, I want to go to somebody that builds it, and I want to ask.
Sounds like a good idea.
Yeah. The problem is that there's only one or two companies. Well, there's three now actually. You've got a Conco, and then you got the other guy that we're talking about, and then we've got. What is the name of that company? I just sent them a 3000 for them to test rebuild.
Oh, wow.
They're out of like Connecticut or North Carolina or something. Yeah, they're doing tubes now too.
What do they get for a 3000 now? If you don't have a core, you got to buy a new one. What do you get? About $750?
For a Conco?
Yeah.
Oh no, try more like
$1,200.
$1,900.
$1,900?
$1,900.
About $700.
Richardson's for an actual iMac real deal iMac from Richardson's is like $3,000.
Wow.
For a 3000.
Wow. And then they're about $750.
And then Richardson's now has got some company rebuilding them for them. It's not a Conco, but if you go to a Conco and get a rebuilt 3000, you provide them with a tube, you are looking at $1,000.
$1,000.
Roughly $890 to $1,000, depending on shipping.
Wow.
So,
wow.
Yeah, you don't even want to know what a real 3000 costs, or a real 15,000 costs.
Well, I know what it's.
Not a rebuild.
I know what a new 20. I knew what a new 20 costs.
From Richardson's? Yeah.
No, from Econco.
That's a rebuild.
Yeah.
That's a rebuild. But no, like a real 20 is like $7,000. Brand new, old school iMac, old stock.
Holy smokes.
Yeah, it's getting really expensive. That's why I wanted to go to the Apex place, which is amazing, by the way.
I'll vouch for that. Apex is all. I haven't been there for, I don't know, 8 years, but I need to go back there again.
You don't go there expecting to stay clean. Be prepared to become very dirty, and you take a truck and a lot of money. And you kind of come out of there with a lot of neat stuff. But
yeah.
It's the first place I've ever been to that sells Teflon wire by the pound.
Wow.
Pound, not by the foot.
Right.
By the pound.
Yep.
Yeah, I don't care what gauge it is. How much does it weigh?
Same thing. You can go to our little place. You might want to stop there before you leave here.
Why don't we go there now?
I'll give you a. You know what? Let's go on a little trip down the road.
We got the little thing going on in there.
Okay, let's finish that. We'll take a little trip down here to my favorite little scrapyard, and they've got a whole area that's all wire. Ooh. And you never know what you're going to find. Oftentimes, sometimes Teflon, sometimes non-Teflon, but by the roll, and it's by the pound.
What the hell is that running over there?
That's my audio processing stuff. That's Live Professor. And the bottom two, what you're looking at right now, these bottom two plugins are my playback plugins. They are just strictly for whatever comes off that computer so that it doesn't overmodulate its transmitter. And then I have all these plugins right here.
I don't know, I've just been sitting there looking at that this entire time. Oh, that's how
does
you
all
do.
my audio processing.
Look at the EQ curve system on that. That's neat. It's like, looks like you're tuning a race car over there.
Yeah, so
He's going to do a lot of YouTube video about this, I have a feeling, in the future, maybe.
Maybe. Audio processing is one of those things where you will seldom find two people that agree on the same way of doing anything. And there are so many ways to do the same thing, and there are so many different paths you can go down. So it's like the engineers at a broadcast station. If you look at all the different commercial broadcast stations in different markets, they'll share all kinds of information with each other, except for audio processing. Even if their processor is nothing more than a simple 9100 or an 8100A or something like that, they will not share the settings that give the station the signature sound, since the processor is what determines that in both an AM or an FM station. So to get into a discussion with people about processing and how you achieve what you achieve, very few people are. I can have that discussion with somebody like Prime. We are on the wavelength. We know what we're talking about. We know where we're going and what causes what and how things cascade and work together. But average people, I mean, I've even seen video on YouTube of somebody saying, well, here's my rack, and I can eliminate this, and this is what it sounds like. I can eliminate that, and this is what... They don't realize that they can't do that, because the output level of a stage you just eliminated changes what hit the stage after it. So the stage after it's not going to work the way it was in the environment that it was in with the other stage before it activated. So you can't really say this is what this does, this is what... You can say this is what this does by itself, and this is what this does by itself. But don't tell me that this by itself, if not present, is going to make the rest of it sound like it minus that, because it all interacts together. So it's next to impossible to tell somebody what to do to make their audio sound how it sounds. Your voice at Prime's place with Prime's processing on his Pro Tools was unfreaking real. I remember my jaw dropping when I heard you on his session.
Because I'm such a duck now, you know.
I tell you, his session was his session, but your voice on his session was something incredible, and that's why the first thing I asked you, are you going to get the same processing and set it the same way? Because that was the ticket, man.
I went out after that and I bought the radio.
I know you did.
Sitting in a box at my house.
And it's like the whole thing about the modulator. You bought the radio. The radio is not what made or broke the sound. The modulator would sound the same way.
The radio allows the flexibility to drive the thing.
The audio
down
processing
stuff. I know, but
and if I
that
could talk
takes time, John. That I don't have. Remember, my hands
you
are made for making boxes. I don't have a month to spend digging around my audio.
You just got Sweet Talk Prime into giving those plugins and that session and that setup. And if you had that, my God, unbelievable. Yeah, but.
Once again,
to come up with that
was a year and a half ago, and there's probably this much dust on top of that box.
Right. Yeah, you haven't broken it open yet.
I don't have time. Imagine this space full of other people's stuff I need to fix.
I know.
And there's somebody out there right now, this minute, damning me because I'm sitting here talking with you and not at home working on their stuff. I can guarantee it. I guarantee it.
Blame me. It's all right. Hey, your box isn't done because I'm here shooting the bull with BBI on YouTube.
Just be kind and forgiving. That's all I ask. Well, that's it. I'm going to wrap this up. All right, we're going to pull the cord parachute. We're jumping out to plane.
Sounds good.
I appreciate making so much time the last 2 days for us.
Man, it was fun having you and Steve come up here. It was awesome. Those tomahawk steaks were out of this world.
I'll interject a picture now.
Okay. Yeah.
We took a ton of pictures. I can't believe we were going to get 3 of those.
Jackie's jaw dropped when she saw those steaks. She was like, So that was awesome.
Yeah.
That was awesome.
Well, sir.
All right. Good to see you again.
Good to see you too.
Gotta make the yearly stop.